Uh, Good day, guys, once more. So, one of the things that I wanted to emphasize is that for you to solve the titration problem, you must know the nature of the reaction. Meaning, you must know how to balance the equations that are there. And for a back titration, you must know that there should be two equations, always. So if you just have one equation and you don't know how to balance, like in our test one, some of you are failing to balance. You must pull up your sources so that you are able to solve these things with relative ease. So when you balance the equation, remember that the first thing that you find is what was in excess, so that it gives you how much has reacted with your desired substance. So those are the scenarios. These are simple concepts, guys. Always just know that chemistry is simple. Ask me as many questions as you can on the platform. I'll try by all means to explain the best way that I can explain. So one of the things that I want to emphasize on now is that most of these reactions that we use in this topic, most of these reactions are those, like for the acid base, we use strong acid and strong base, meaning those ones that react completely, those that ionize completely in solution. Like hydrochloric acid ionizes completely, nitric acid ionizes completely. That's a strong acid. So if you have a strong acid, then to ionize completely, then you just react it normally. But if you have a weak acid, like acetic acid or propanoic acid, then for that one, those acids, you must have information about chemical equilibrium. You must have information about chemical equilibrium. So what is a strong acid? Remember, it's that one which ionizes completely. What is a weak acid? That one that partially ionizes. The partial ionization in acetic acid, the lemon that we eat, is in the range of 1% to 5%. Meaning, if you have 100 grams of lemon juice, the only acid there should be 1 gram to 5 grams, which is very small. That's the reason why we're even able to eat lemon. But you can't dare even drink HCl in the lab. If you do that, you are committing suicide. In fact, you won't even commit suicide, you become lame. Why? Because the acid will knock off your teeth before you even swallow. So those are dangerous acids. That's the reason why they are dangerous, because they ionize completely. That's why you find they even have danger signs. So those are the scenarios. Then one of the things you must remember is that to define acid, you should make sure you emphasize if you're using Arrhenius or Bronsted. Bronsted is the one that we learn the most now, because we know that you're reading of Arrhenius in your grade 12. So Bronsted tells us that the acid is the one that donates a proton. And what is the proton? It's the hydrogen ion. Why is it the proton? Because hydrogen only has a proton and an electron. So when it becomes the ion, it has lost the electron, and all it has remained with is a proton. So anything that gives out hydrogen ion, then it's acid. The acid, according to Bronsted, can be anything, including water. So those are the concepts that you must know. So go and revise some more, and then I'll explain some more on equilibrium. Thank you, guys.